on a long time. I think he'll introduce himself as well.
Thank you very much. My name is Paul Irofti, and today I want to talk about the work I did on the Octeon machines. I want to take you through the drivers and the obstacles that I faced during the last year, or maybe year and a half now. And I'm going to wrap it up with what's coming to the OpenBSD port. Who am I? I'm a reverse engineer. I work for 6 years now in the antivirus industry. I designed an emulator for antiviruses, and I also wrote different static and dynamic engines. I'm also an OpenBSD hacker since 2008, I think. And I didn't really find a single spot on which to focus on OpenBSD. So I started with really easy stuff like ACPI and power management. Coming from a reverse engineering background, it looked appealing. Little did I know, though. And then I moved to Lungson, which is a MIPS64 machine that the Chinese produce. And it's supposed to be entirely open sourced as far as hardware goes, but of course it's not. Because there's one piece there, which is called the embedded controller, which does just that. Embeds all the control in a single chip of the entire machine. And it's not documented. So that was supposed to be fun, ended up not being so much fun, but at the end of the road, you say, yeah, I did that, it was nice, so it was fulfilling in the end. And because of that, I got to see how a MIPS64 machine works. I moved on to Octeon later on. But in the meantime, I also do Compat Linux support for OpenBSD because, well, when I first started working at Bitdefender, I wanted to use OpenBSD, and the IDA, which is a reverse engineering tool, wasn't working on OpenBSD. So I used. They have a port for Linux, so I used Compat Linux for that, and it used to work. I haven't used it for a few years now. I don't know if recent versions work, but they should. And also, I port miscellaneous applications to OpenBSD, which is the most fun thing to do because it's a lot easier than the rest. And you actually get to see things working, not just panics and blue messages popping at you. And if that wasn't enough, I'm also following a PhD in a very well-connected subject of parallel computing on the GPUs, which has nothing to do with anything so far. But it's very interesting as well. I do signal processing, and I'm about to finish my PhD. I have some courses on parallel programming at the Faculty of Computer Science in Bucharest. So that's about it. Once a year, I go out and have fun. How did I get in touch with Octeon? It was almost random. As I said, I played with other MIPS64 ports. I tried SGI for a bit, but I couldn't get it working, the model I had, and Miad finally did that for me, so it wasn't interesting anymore. But then I had a first contact with Octeon during the Toronto hackathon, which was a very good hackathon for me, but had nothing to do with Octeon, besides the fact that I sit next to Jasper, who was hacking on this small box, always mumbling stuff in Dutch. Yes, thank you. I was Netherlandese? No, Dutch, thanks. And I like when I see people angry because I can understand that and I can relate to that. So I kept asking him what's going on, and he was working on a bootloader for this Octeon machine. And it was really interesting. I was mostly looking at his console output and following my work for a few days, but that got me interested, and I wrote a small phrase in the Undeadly report, which is the OpenBSD journal, about this experience. And Diana, which was kind enough to write me an email right away, so do you want one or what? And I was like, oh, well, okay, I didn't even think about that. I was just telling a story about the hackathon. And soon enough, I got a DSR 500 machine, which is a D-Link router switch that's based on Octeon. And that's how the nightmare started. Because I was looking forward to this, and the first thing to do when you get a box is open it and then try to boot whatever is in there. But of course it was running U-boot, which is very popular with ARM people, and you can see that because U-boot has 1,000 variations, just like ARMs. So there's no coherency. You can't read a single document and see how you're able to program that. So I was lucky enough to learn how to boot a kernel through other people's work and hair loss, since I have enough hair now. But Miod was not so lucky, and he wrote most of the instructions that don't really make sense. Typing boot Octeon Linux -BSD is kind of schizophrenic, but anyway. Once I got through that, I managed to go all the way through the copyright, and then the kernel crashed, which was awesome. Actually, I'm really excited when I see that, because I get to fix things, and I get to talk about things and visit nice places like Bulgaria and meet you guys. So I knew this was coming when I saw that crash. So looking at getting past the copyright, which is not so interesting, I had to look at how the Octeon memory is organized. And it's split into chunks. You don't really expect to have a lot of memory on an Octeon machine. So you have different chunks of buffers that memory gets mapped onto. So as you can see, you got the first range, which is the first 256 meg, the second range, and then whatever else is above 512 gets mapped in the last section. But my DSR 500 had 128 meg, and nobody expected that, because we're in 2010 plus. And it was a small system memory, and the code, the kernel, assumed that the memory should at least have 256 meg, and it was doing this substitution, this subtraction here, which of course ended up with me having terabytes or petabytes of RAM, because it overflowed. So fixing that, I got a big reward, but I was a bit scared because I got all the way to Userland. So there was nothing to fix. So we're 3 slides in. I couldn't present something with only 3 slides. So, but I was kind of happy. And I started looking at the dmessage for more problems, and there were plenty. Even though the dmessage is really short, if you're used to AMD 64 dmessages, which take like 10 pages, this was like less than a screen, which is very nice because you can see it all at once. So first of all, OctCF is short for Octeon Compact Flash, which is not configured, so no internal memory. Awesome. This memory address conflict coming from the PCI address space, which I still haven't fixed today. And then there's the PHY to which the network was connecting to, the network adapter was connecting to, and that means unknown PHY. So there were some problems there. So I was kind of starting to get a bit excited about the machine again. And also there was no symbol table. What that means is that when you get a crash, you only get hexadecimal output on your screen. No symbols. That means no trace, no parsable trace. Once you start reading in hexadecimal, Cyrillic seems fun. So where to from here? I wanted to add more drivers, which I did, and I'm going to talk later on. I wanted storage support and networking, of course. These things seem important for a port. And I especially wanted to help Jasper to improve the second stage bootloader in order to get the symbols and make my life easier, which didn't happen until today. But we worked on the bootloader this year in the summer in the hackathon in Ljubljana in Slovenia, and it's getting there. So the end goal being we should have a port that's able to stand on its own, and the users, which I hope to be amongst, should be able to just create a cheap router or switch out of the Octeon and get the sweet OpenBSD message from it. So then, when looking at drivers and implementing them, I had got my first major disappointment, which is the SDK license that comes from the KVM people, the guys that produce Octeons. And they were very nice to open source all their SDK for the drivers, so you only need to call a few functions and hook them up to your kernel. But the problem is that they have this, it's almost like a BSD license, except for the US export clause, which we don't use in the project. I don't want to get into politics because I don't understand them really, but since the project decided that, and I kind of agree with it, we need to be coherent, we have no such license in the tree, I couldn't use it. So I mailed the guys, I sent an email, I got a lot of replies, towards 0. The weird thing is that the SDK covers USB, random number generator, I don't know, network card, everything, every driver. And they also have a crypto accelerator, which I'm guessing it's why that clause is there. And I asked them if they can just resume that clause to the crypto accelerator that they have on the chip. But I got no answer, because I think that's why that got there, and then it was just copied over and over. So I wanted to start with a simple driver, because I wanted to see how the registers look and how I could use the Octeon without the SDK. So I wanted to start with the random number generator, which should have been pretty easy, because I just need to start it, get the output, and feed it to our random number subsystem. So I started looking at the magical figures that the SDK is using for the control register for the random numbers. And it's as easy as I expected. You just read the control register, make sure you set up the output, you set the output and the entropy flag, and just after you write it back, you should get randomness from there on. So you just do this once during boot. So the numbers are written in the entropy register, which is different from the control one. You feed it to our API for randomness, and then you keep reading every 10 milliseconds. Easy. The obstacles I faced, this was actually the driver that took most of my time, I think, was because of endianness. So the the register addresses are written in a different endian in the SDK than what you're supposed to feed there, to feed to the control register. So if you want to do an actual read and access register, you're supposed to flip all the bits, because that's why. I don't know why. So besides that, there was a read after write required whenever you set the control register, just to make sure it was actually written there, which is not uncommon, but still, for something as simple as that, I didn't expect. And another, when I finally got the driver, I was feeding 8 bytes of data, but I was told that only 4 are needed to be fed to the random subsystem, which you can ask VOY tomorrow during his talk. Moving on, I got a message every time I did NFS boot, which is really annoying because it's in caps, and you know, IRC culture, you get bleeding eyes when you see caps. So I want to get rid of that. So because we didn't have a clock, we only used the file system to get the time of day clock. And the Octeon boards have some really good clocks. I mean, the Swiss must be proud of this technology of clocks of a 1 second resolution. I mean, they're awesome. And they're the ones that are used to get time and set time for the time of day clock. If that wasn't scary enough, in order to get to the clock, you need to use a 2-wire serial interface, which is a twisted way of getting across to different devices. So you get stuff like an internal address of that serial interface, and you get nice things like a read bit, which needs to be checked if the serial interface actually read what you told it to read, and all kinds. The valid bit, it's very stable and robust, and you get like all this 32-bit metadata just to write 32 bits, which in the case of the RTC clock is even less. But sure, it's supposed to be like this. So you set the address field for the real-time clock device, and afterwards you just use internal addresses. You don't use the entire address to access the time clock. And you set the operation of reading or writing in the metadata that I showed, and you just do reads and writes from the data field. That should be easy. I don't know why I'm complaining so much. Well, maybe because you do it in 2 steps. The first being that you need to set the read bit in order to read something from the RTC clock, and then you need to set the valid bit. This is done in sequence, of course. And you need to write to the register, which is like controlling the entire interface and telling you what to do. But the second step, you need to read back and keep reading back until the valid bit is set. And if that is cleared, then the operation was done, and you can get a byte of data. Awesome. Which is 1 second resolution. So you have enough time to loop. So, yeah. And the writes are done in a similar fashion, in that you set bits in order to write, and you finally configure that register for a write, and then the second step reads back what if the operation was completed, and loops all over, except with the extra bit of having to read back even after you got the valid, the OK. I wrote there, you still have to do an extra read. So afterwards, you get useful information. Everything is BCD coded, which, yes, it's good, I guess. And you get to feed the set time and get time routines, the BCD formatted data. So that got me to a real-time clock. But of course the issues, if it wasn't obvious so far, is that it's very fragile. You need to read, there are a lot, if you're looking at the code, if you have nothing better to do, there are a lot of checks, integrity checks there, because of the loops, and it can actually even time out, I think. It's complicated. And some models don't even have a real-time clock. So when I committed it, I expected everyone to have a real-time clock, but some just panicked because there was nothing there when you tried to read or write to that real-time clock, like the Ubiquiti edge router. So buy that. Moving on, I was able to NFS boot without the caps, but you know, in order to NFS boot, first I had to TFTP boot. All of these involve a network, which was working until I reached Userland, when I couldn't even ping. I couldn't do anything. I didn't get media, and the status was no carrier, so it was like no cable connected. But that far, it could reach the network. So I wanted to fix that, of course. Looking at the missing PHY for the Broadcom device there. Remember the unknown PHY message from the dmessage that I talked in the beginning, I started looking at other people's work, which is what I mostly do because I don't really like to work. I like to get other people's work and adapt it and call it mine. So OpenWRT had a wonderful driver for it, which I adapted and trimmed down for different reasons. I basically just got the values that I need to read and read from the media information. Because the OpenWRT driver was a lot more complex and was doing a lot more things like switching, which we don't have support for in OpenBSD for doing multiple port switch and like the Z router project from FreeBSD and stuff like that. So I wrote a minimal driver which does dumb mode switching, so whatever you plug in there it sends out. So I need to get to the status of the file to see if the link state is okay, if what kind of mode we're in and what the speed is. So this was done through registers from read from the status page of the file. So in order to get that, I need to make sure that I'm on the right page. And of course, you need an extra readback operation even after you set the page that you want to be in. And then once you're in the right page, you get the data from there in 2 bytes of data that tell you what the CPU port is doing, so what media it has, the link state and everything. And for the next ports, you get the inflow in the second, third, and fourth data registers. My DSR for 500 has 4 ports, so that's why. So after that, I got media right here, and I could ping. So network was working, which is really nice to have on a router. So for the switch support, I was planning on integrating one of the 2 frameworks, the Z router one, which I am more familiar with because I was in contact for a lot of time with Alexander. And there is also the IIJ solution, the IIJ people from Japan. They have a commercial support for the Octeon based on OpenBSD, and they open sourced a solution for the switch framework, which I tried to integrate into OpenBSD during the Ljubljana hackathon this summer, but the guy developing that was very busy and we couldn't sync in order to discuss integrating it. Moving on, the hardest part is the USB support, because the compact flash, even if you have a driver for it, it's like 32 meg. So the Z router people are stripping down FreeBSD in order to fit in that compact flash. And then they have USB support for the KVM SDK, so you can add extra storage. So there's that driver. And then there's the IIJ driver, which they also open source, but they only work for the 3000 models of the KVM machines. And it's also very specific to the machine that they sell, and it's not really working on the machines that we support. And then there's my driver, which I finally got to a point where it no longer fries sticks. I managed to fry like 4 or 5 memory sticks with it, with a small spark coming out of it when I plugged them in. That was lovely. So I'm going to talk about that wonderful implementation I did. I started by doing the machine-specific, the host controller-specific initialization routines, which is clock setup, core setup, DMA, and setting up a proper interrupt. And this was pretty much stealing magical values from the SDK or looking at what the IIJ people did. It's always a mix, so I always had like 4 or 5 virtual screens with exterms to their code. And once I did that, I managed to get an attachment. So the Octeon host controller was attaching to USB 0, which I know Doesn't sound like much, but to me it was a glorious day. And I even got some error messages, so more work, awesome. So I wanted to fix those. And the first thing was to add an interrupt routine, which is it's really easy to start with. You just add bits of pieces there, but the memory sticks keep frying whenever you think you're making progress. So the best thing I did was look at both implementations and I was able to make a coherent interrupt routine that looks, if you open other host controller drivers in OpenBSD, they're going to look the same, and you're going to spot the machine-specific bits when looking at the two in parallel. So I think that's nice. Even if I have an accident or whatever, MPI can come over and finish the driver for me. Oh, by the way, I never looked at USB before this. So this was also a very nice experience to start learning about a different layer. And MPI, which is USB master nowadays in OpenBSD, was very kind to answer my ridiculous questions. So after I've finished the interrupt routine, or so I thought, I keep adding code to it, I got a proper D message without those errors. That doesn't mean that it was working, it just the messages went away. So I moved on to adding root hub support, which is like the media support for the PHY. You start notifying people about what's happening in your hub, which is the status. You get the descriptor of the requests that are sent to the hub, and also fixing the USB 2 descriptors, because you have to register the host controller as a USB 2 controller. Fixing those and acknowledging the fact that I was getting commands from outside helped fix the frying problem. So I was able to plug in things without sparks, and I was able to use the devices afterwards. So this was, I'm not sure if it was progress though, because some people offered money for the driver before, just to be able to make pranks on 1st of April to people. And but in my point of view, it was progress, because now the USB port was doing the same thing as before, nothing. You plug in a device and you get nothing back. You pull it out and it still works. So back to back to the basis. And then in order to actually get something out of the USB host controller, I started adding more support for USB ports and endpoints. Of course, they call endpoints channels. That took me a long time to figure out. I was like, channels, what's that? I was asking MPI, do you know a channel definition in the USB specification? No, what's a channel? So that was fun, changing that name. Thank you. So these allowed me to keep track of when you connect to a port or when you do a port reset. And I was able to send notifications upstream about what was going on. And this actually moved things further, as nowadays I need to implement device transfer and control methods, which in terms of the actual devices means that I need to start sending data through, so the control is almost there. Because to give a large picture, the green things are things that are done, and the blue things is what I'm working on, and the red is what's missing. So you might think it's half and half, but you're being overly optimistic. It's just so that I can show that I did something. This will take a lot of time, and it's very sensible work here, but at least it's not destroying devices, and it's you're able to actually see how things are moving in a USB stack, and not getting panics, just not moving data or not detecting the proper events. So this is the point where I am today. As I was saying, the boss the bus methods are done, and the hub routines should be okay-ish now. So I'm moving on to devices. So the major showstoppers, because I'm working on this for a while now, is the SDK, which you would have. The SDK is like 2 function calls and you're done. You have a host controller. Nice, right? And the fact that the SDK and the IIJ code is very different, and they actually set registers in a different way and in a different order, and it's a lot of guesswork and poking and going back to reverse engineering. And USB is really hard. I mean, like, the spec is hard enough, and doing it without the proper documentation is even harder. And the time requirements are really high, and I'm one of the people that need to focus on a task for at least 4 hours in order to get something done. I can't just work for an hour in the evening after I'm done with regular work on the USB, because I need to get in there and remember where I left off and start thinking about the magical values in this part of the world. So progress is slow because of that. Moving on to the flash memory, I started working on that as well as time off from the USB layer, which is it's supposed to be really easy to implement. It's a compact flash after all. The FreeBSD has a driver foot that's going through CFI, and I wanted to get the code from there, and I probably will end up doing that. The problem is that they have a lot of layers that they go through, and I just want to get the core of the driver. I'll show in a later slide, I think, the layers that it goes through, or maybe we can see it here. Yeah, the CFI, it's a CFI-D connected to a CFI-0. They support a lot of compact flashes because they respect this specification that Intel, AMD, and other people agreed upon. And it's different because, of course, Intel or AMD decided to violate that and do things opposite. So a lot of if-defs. And I have never done a disk driver, so I discussed with DLG, David, about it because he's the authority in this domain. And the idea is to write a small ATA driver for it. But the problem is that this device is so dumb that it's not using most of the ATA things, so it doesn't do concurrent commands. There are no port multipliers. It's just so easy that the ATA might be even more complicated than what the FreeBSD people are doing. So the idea now is to avoid doing something like PCIe, which is does a lot of layer violations, and to do standalone driver maybe, because the reads and the writes are done through registers. You don't do DMA. So I'm still changing the implementation every time I'm going back to it. So I haven't settled on a direction. So this is as I was saying, I don't know if I should support the entire CFI specification. This is an extension of it. I don't know if I should add that. Maybe I should start small. I don't know. So progress on this is really slow as well. So to conclude, is a lot of work was put into it, even though it's not so obvious. The lack of documentation, as always, is slowing things, and the SDK copyright is making things even harder. And I would enjoy to have to get some help in these open problems there. And I will continue working on the port, and I want to complete it as soon as possible to make it standalone. The memory storage being the main problem with it nowadays. So thank you for listening to me, and questions?
this thing where you had to loop over the real-time clock just to be able to
Mhm.
write one byte and wait for the valid bit to change value. How many times do you have to loop over that before it actually accepts what you're trying to tell it?
I haven't. I measured it a few times, and it wasn't that bad actually. I mean, it seems that it's rarely occurring. The problem there, you always get it the first time, most of the times. But
Okay.
sometimes you can get like 3 or 4 iterations before being able
but
to.
there was no,
But that's
no crazy
rare.
amounts like 10,000.
No,
or
no,
something
no.
like
It's
that.
not that bad, but it's it's tricky. Yeah.
So I know it's not good, but did you try playing with SDK to see if it would be easier, actually?
I tried to play with the SD, meaning to integrate it and see
Yeah.
how the USB works. I tried that with FreeBSD, and it works really good, and with the Z router, but not with the actual OpenBSD tree, because it's not so easy to integrate the SDK. I mean, it needs a bit of work, so I prefer to play with other projects that already did that work and try to,
Well, it can give you some pointers so that you don't have to reverse engineer everything.
Yeah, no, I'm looking at the SDK and I'm helping myself from there with different values and stuff. But the logic, it's really like it's the abstraction they use is very deep. So you have to, in order to read the register, you go through like 10 or 12 functions until you actually do the read operation, because they call it from different places and different drivers, and that makes sense for them. So integrating that into OpenBSD would take a bit of time. It's not impossible, and I know that it won't get committed because of that license.
Of course.
Yeah.
Thanks.
How finicky is the hardware that you are working with to debug? Does it have a convenient serial console? Or
Yes, it has a serial console, which is like serial, not JTAG or whatever.
So no soldering necessary?
No, you
Okay.
just buy it and you plug it in.
And there was the D-Link that you were working with?
Yes, D-Link, DSR 500, but I think the others are the same. I don't remember anyone having to solder a serial, but I might be wrong. Yep. And it actually comes up as a PHY as well, the serial, because you get like a network cable on one end and on the other, the actual serial cable. It's, works on the fly.
That might be a very generic question, but are those devices popular? The D-Link, are there many devices using Octeon? Is it
Yes,
popular?
D-Link has a lot of models using that. They even have
Mhm.
wireless. Mine only has wired network. Some have wireless. A lot of
Mhm.
people are using it because it comes with a product. I mean, the D-Link I have, I could use it right off because
Obviously.
they sell those. It's not like I have to write an email and they send me prototypes.
Mhm.
So yeah, a lot of people seem to be using that. I'm not sure if the DSR 500, so to say, but there are a lot of Octeon models produced by the D-Link, and not only them, but yeah.
Mhm. Okay.
Yeah. I think Claudio.
So can we use these devices for like firewalls and stuff already, or is it not really good?
That's what I want to do. I have a server that's running since 1996 or 1997, and I wanted to, once I got this, I wanted to do the PF thing on it, and I didn't test with OpenBSD, but FreeBSD works. Yeah, sure.
Yeah.
But they're using the SDK, so I don't know if the PHY needs further work or maybe some. But yeah, looking at the OpenWRT driver, we have most of the things there. So I haven't tested with OpenBSD for like actual performance, but then I only run a home server, so I'm not the speed junkie.
Yep. So
Yeah.
you don't know how fast it is.
No, I don't know that. But you should ask JMFU or DLG, I know they experimented stuff on them, and because they're building the infrastructure at the university, they probably looked at the networking figures. So, yeah.
Further questions? We still have time, as far as I can tell. So, well, then again, we stole some of their break time earlier. So, if there are no more questions, let's thank our speaker.
Thank you.